This is video 4.1 for Algebra 2. Today we are starting matrices. Matrices are really fun. I've never really seen them introduced in Algebra 2 before, but I think they do a really great job of introducing it so that when we get into really doing the hard stuff with them in pre-calculus, you've seen them before and it's not brand new. So all a matrix really is a way of displaying and working with data. So it is what was called a rectangular array of numbers, and it's enclosed in a bracket. So it would look like this. This would be matrix A. So in this case, it is a 2 by 2. That's going to be its dimensions. When we talk about dimensions, the first number in your dimension is going to be how many rows. So this is 2 rows. And then the second number, the n in there, is going to be identify how many columns. So here we've got 2 rows, so that's a 2. And then 2 columns, so that would be by 2. So we would call this a 2 by 2. Something that has the same number of rows and the same number of columns is called a square matrix, but they don't have to be square, all right? Now, each of the little entries inside of your matrix, that's going to be the value. So let's say this one has an address. And this address is going to be, if it doesn't have a specific number in there, it's going to be identified by the matrix letter, only lowercase, and then it's got 2 little numbers. You can see that each of mine have 2 different little numbers. So our first number identifies the row that it is on. So here we have row 1, row 1. This one is row 2 and row 2. And then the second number identifies the column. So this is column 1, column 2, column 1, and column 2. So let's practice putting some data into matrix form. So here we have some information about packaging cost given for whether or not the box is plastic or paper. So we have total cost, we have cost per square inch and cost per cube inch for the these type of packages. So what we're going to do is we're going to display the data in matrix form. So rather than writing all of the numbers and stuff, all we're going to do is we're going to take the data. You may find it easier to draw your brackets afterwards actually, because I'm never very good at drawing it as big as I need it to go. So I'm just going to put it in exactly like it would be in the table given. They need to be nice and orderly. So the columns need to line up and the rows need to line up. So on notebook paper, it's a lot easier to do than on non-paper. And then you put a bracket on it. That's all you'd have to do. So what are the dimensions of our matrix? Remember, you do how many rows by how many columns. So we have 1, 2, 3 rows. And then we have 1, 2 columns. So we would say this is a 3 by 2 matrix. So what is the entry that is in a C12? So C is going to be the name of our matrix, so we're calling this matrix C. 1 tells us we want to go to row 1, column 2. So we're going to go to row 1. So you start with your row, go over to the column that's given. The entry there is 0.72. So let's go backwards. Let's find the address. Sorry, let's find the address for the information 0.005. So that's right here. So first we go down to the row. So the row it is on row 2. The column it's in is column 1. So we would say its address is C21. Now, if you have 2 matrices, you can add and subtract them. When you do, what you're going to take is you're going to take corresponding entries. So like entry 1, 1 for each matrix, and either add or subtract just those 2 digits. So this would be kind of what it looks like. We have matrix A and we have matrix B, and their numbers are the same. So you've got 1, 1 and 1, 2, 1, 1 and 1, 2, 2, 1 and 2, 2, 2, 1 and 2, 2. So the real rules are if your two matrices are the same dimensions, you can add and subtract them. So your answer is going to be, you're going to take your A11 and your B11 and add those together. Then your A12s and your B12s, and they will go in the spot for the 1, 1 and the 1, 2 in the corresponding matrix. So let's try it. So all we're going to do is we're going to take our 1, 1s and we're going to add those together. So this is 1 plus 3, and then it would be 2 plus 4 right here, 3 plus 5, so we're doing this too, and then 4 plus 6. So if it's confusing to you, go ahead and write out the little steps. If you can do in your head, and you can say that 1 plus 3, you've got 4, and then 2 plus 4 is 6, 3 plus 5 is 8, 4 plus 6 is 10. And go ahead and write your answer matrix, that's fine. If this is a step you need to do for a little while, that's fine as well. Now remember, you can only add and subtract them if they have the same dimensions. So let's find some sums and differences. So here's 4 matrices that we're going to use. Let's find A plus C. First thing we need to check is, are they the same size? Can we add them? So 4 is a 3 by 2. I'm sorry, A is 3 by 2, and C is a 3 by 2. So since they are the same, we can add them. So I'm going to do my 4 plus my 3. I'm going to do my negative 2 plus my 2. Negative 3 plus 0. 10 plus negative 9. 2 plus negative 5. 6 plus 14. So my answer matrix is going to be a 7, a 0, a negative 3, 1, negative 3, and 20. Let's do C minus A. So we're going to use the same data, or we're going to do different things to it. So let me erase all of those. We already know C and A can go together because we've already done that they are the same size. So this time I'm going to start with this matrix over here. So I'm going to say 3 minus 4, and then I'll have 2 minus negative 2, 0 minus negative 3, negative 9 minus 10, negative 5 minus 2, 14 minus 6. So my answer then is going to be 3 minus 4, which is negative 1, 2 minus negative 2, which is 0. No, it isn't. It's 4. So it's really 2 plus 2. So that's 4. And then 0 minus negative 3 is going to give me negative 3. Negative 9 minus 10 will give me negative 19. Negative 5 minus 2 gives me negative 7. And 14 minus 6 is going to give me 8. So you can see that by doing the operations differently and switching the matrices, it's going to give us a different answer. Let's do C plus B. So remember, the first thing we need to check is, are they the same size? So can we add and subtract them? So this one is a 2 by 3, and this one is a 3 by 2. So those are not the same. They have to have the same number of rows and the same number of columns. So this one, they cannot be added. Another thing that you can do for matrices is you can multiply them by a single number. Let's say we had matrix 1, 2, and we were wanting to multiply it by a 5. So what you would do then is you're going to basically distribute that 5 to everything inside the matrix. So we would do 5 times 1 is 5, and 5 times 2 is 10. So that's how a scalar works. And a lot of times they would be used in applications where you're selling something, a service or a product, and you mark that up. The markup is going to be the scalar that changes everybody's prices. So in this problem right here, we have that a ticket service is selling tickets to the rodeo. What they do is they take the tickets and they increase the price by 150%. And so we're going to find the new marked up prices. So the first thing we're going to do is we're going to take our data here and put it in a matrix. So we've got 60, 50, 80 in the first column, and 35, 28, 45 in the second column. Let's find our scalar product. So we're not going to multiply by the 150 because it's a 150%. What we're going to need to do is change that to a decimal that would be used. So 150% is the same thing as 1.5. So that's what we're going to multiply it by. So when we multiply everything by 1.5, we would get 1.5 times 60 is going to give us 90. And then 1.5 times 50 would give us 75. 1.5 times 120 is going to, times 80 would give us 120. 1.5 times 35 will give us 52.5. And then 1.5 times 28 will give us 42. 1.5 times 45 will give us 67.5. So this is how much the prices get marked up by. So the actual prices that people would pay for their tickets is going to be our 60, 50, 80, 35, 28, 45, plus our new markup number here. So it'll be plus the 90, 75, 100, no, it's 100, 120, 52.5, 42, and 67.5. So the ticket prices, if you were wanting to go to this rodeo, you would end up spending $150 the first day or second day if you wanted in the plaza, $125 if you were going the third to the 8th day, $200 if you're going the 9th to the 10th day, closing days. Your balcony prices would be $87.50, $70, and $112.50. Pretty steep markup there, but that should make sense because if you did something by 100%, then you've doubled it. So 150% is going to be 1.5 times bigger. So those are going to be expensive. So you can see that we can take scalars and addition and subtraction and use them together. That was going to be called simplifying matrix expressions. So let's do a couple of those. Let's evaluate 2a minus 3b. So remember, the first thing we need to find out is, are they the same size? Can we even do that? So this is a 2 by 2, and our b is a 2 by 3. You cannot do this. Cannot be done. So there, we don't even have to do that one. Let's evaluate c minus 2a. Let's check that, make sure we can do it. C is a 2 by 2. A is a 2 by 2, so we can very much do that. So we're going to do C. Let me rewrite my C here. 3, 0, 2, negative 9, minus 2 times my A, which is 4, negative 2, negative 3, and 10. Let me rewrite my C. 3, 0, 2, negative 9, minus, and my new a, I'm going to multiply everything inside by my 2, so I'll do 2 times 4 is 8. You know, actually, rather than doing the minus right here, I'm going to have my minus with my 2. So I'm going to change this to, it's going to become an addition because I'm going to distribute my negative 2 to everything inside. So I'm going to do a negative 8 here, a positive 4, a positive 6, and a negative 20. So now I can add them. I'm going to do 3, 3 minus 8, which is going to give me negative 5. 2 minus 4, which is going to give me negative 2. 2 plus 4, which is going to give me 6. 0 plus 6 will give me 6. Negative 9 plus negative 20 will give me negative 29. So you can see that you have to be careful with your signs. So just a couple of properties of equality. These work the same for matrices as they do for normal addition and subtraction. So the commutative property that says you can add them in either direction. So for normal addition, it would be like 2 plus 4 is the same thing as 4 plus 2. So for a matrix, let's say we had 2, 1. That's the same thing. Let's say we had 2, 1 plus 3, 4. So that would be the same thing as saying 3, 4 plus 2, 1. But they would have to be in the same order because 3, 4 plus 2, 1 is not the same thing as 3, 4 plus 1, 2. And then the associative property says that if you've got 3 numbers that you were wanting to add together, like 2 plus 3 plus 4, that you can either do that as 2 plus 3 plus 4 or 2 plus 3 plus 4. And that's the same thing with matrices. If you've got 3 matrices that you're adding together, it doesn't matter which order you add them in. The additive identity that says anything plus 0 is itself works the same way for matrices. Let's say we had matrix 2, 1, and we added that to matrix 0, 0, you would get 2, 1. And then the additive inverse is that if you add your opposite, like 5 plus negative 5, you would get a 0. So the same thing works for matrices. Let's say we had a 2, 1 again, and we added it to negative 2, negative 1. We would end up with a 0 matrix of 0, 0. And if you end up with a matrix of 0, 0 after you add 2 together, then they are additive inverses. That's it. I know it's a little bit long, but I hope you enjoy doing matrices. Have a good night.